In this lecture, we are going to see the concept of algorithmic problem solving in computer science. We are going to see its definition and the various steps involved in it. All right, let's get going. The definition: algorithm is a step-by-step procedure to solve a problem. It is a precise rule or a set of rules for arriving at the logic for solving a problem. The step one, understanding the problem. That is step one in algorithmic problem solving is understanding the problem. Before designing the algorithm, one has to understand the problem, obviously. Read the problem's description carefully and ask questions if there are any doubts about the problem. Step 2. Ascertaining the capabilities of the computational device. This is done after understanding the problem. Sequential algorithm. Instructions are executed one after another, one operation at a time. Parallel algorithm. The central assumption of the RAM model does not hold for some newer computers that can execute operations concurrently. Step 3. Choosing between exact and approximate problem solving. The next principal decision is to choose how to solve the problem. Solving the problem exactly is called an exact algorithm. Solving the problem approximately is called an approximate algorithm. One would opt for an approximate algorithm because there are important problems that simply can't be solved exactly for most of the instances. Available algorithms for solving a problem exactly can be unacceptably slow because of the problem's intrinsic complexity. An approximation algorithm can be a part of a more sophisticated algorithm that solves a problem exactly. Step 4. Deciding an appropriate data structure. In the new world of object-oriented programming, data structures remain crucially important for both design and analysis of algorithms. Data structures can be defined as a particular scheme of organizing related data items. Algorithms plus data structures will give you programs, all right? Step 5. Algorithm design technique. It is a general approach to solving problems algorithmically that is applicable to a variety of problems from different areas of computing. Algorithm design techniques make it possible to classify algorithms according to an underlying design idea. Therefore, they can serve as a natural way to both categorize and study algorithms. Step 6. Methods of specifying an algorithm. There are two options for specifying an algorithm. First one is pseudocode. It is short, readable, formally styled English language used for explaining an algorithm. It consists of capitalized keywords, and there's a separate video that I have made on pseudocode. You can watch that to know further on this topic, know about this topic even further. All right. Flowchart. It is a diagrammatic representation to arrive at the logic for solving a problem. And there are some standard symbols to be used for the flowchart as well. Step 7. Proving an algorithm's correctness. A common technique used for proving the correctness of an algorithm is to use mathematical induction because an algorithm's iterations provide a natural sequence of steps needed for such proofs. So mathematical induction is a concept in mathematics, all right? So they are applying that concept here. The notion of correctness for approximation algorithm is less straightforward than it is for an exact algorithm. For an approximation algorithm, we usually would like to be able to show that the error produced by the algorithm does not exceed a predefined limit, okay? Step 8. Analyzing an algorithm. Efficiency is an important characteristic of an algorithm. There are two kinds of efficiencies. The first one is time efficiency, indicating how fast the algorithm runs. Second one is space efficiency, indicating how much extra memory it uses. Another desirable character is simplicity because simpler algorithms are easier to understand and program. The final step is coding an algorithm. Most algorithms are designed to be ultimately implemented as computer programs. Some computer scientists believe that unless the correctness of a program is proven with full mathematical logic, the program can't be considered correct. Validity of programs is established by testing. Okay, my dear friends, I hope you found this video useful. Thank you so much for watching.